The investigation into the mysteries of Skinwalker Ranch has evolved far beyond anecdotal accounts and speculative theories. In recent years, it has transformed into a technologically sophisticated scientific endeavor, leveraging some of the most advanced tools available to modern research.
The 2025 field season marked the pinnacle of this transition as a coordinated suite of experiments combined high-precision sensing technologies, remote data acquisition platforms, artificial intelligence, and advanced analytical methodologies to probe the anomalous environment of the ranch. The results have not only yielded unprecedented volumes of data, but have also begun to hint at patterns and phenomena that challenge conventional physics. At the heart of this year's operations was the MESA drilling project, an engineering effort as much as a scientific one. Ground-penetrating radar GPR had previously revealed the existence of a massive dome-shaped subsurface anomaly accompanied by a constellation of smaller reflective signatures. These findings suggested the presence of either a structured artifact or a naturally occurring geophysical anomaly with highly unusual properties.
To study it directly, the team initiated a borehole drilling operation designed to penetrate hundreds of feet of sandstone and provide access for in-situ instrumentation. The project faced numerous setbacks. Drill rods detached inexplicably, equipment failed under conditions well within operational tolerances, and structural anomalies interfered with drilling progress. These repeated disruptions were not simply mechanical problems. Their timing and correlation with proximity to the detected anomaly suggested the presence of environmental factors beyond conventional geotechnical parameters. Nevertheless, the team succeeded in creating a 600-foot borehole, an engineering feat that will enable future insertion of diagnostic payloads such as gamma spectrometers, electromagnetic sensors, and borehole tomography devices. Parallel to the subsurface investigation, a major airborne and terrestrial sensing campaign was undertaken employing an array of LiDAR systems with complementary capabilities. LiDAR, or light detection and ranging, is a remote sensing technique that measures distance by illuminating a target with pulsed laser light and analyzing the reflected pulses. Its ability to generate high-resolution three-dimensional maps makes it an ideal tool for detecting physical structures, volumetric anomalies, and spatial discontinuities. This season's experiment integrated 4 LiDAR modalities: a terrestrial laser scanner for ground-based surveys, a mobile LiDAR unit mounted on a vehicle for dynamic surface scanning, a drone-mounted system for aerial mapping, and a helicopter-based platform for volumetric and atmospheric sensing. The synchronization of these systems allowed for simultaneous, multi-layered data acquisition across the ranch's key anomalous zones, including the Mesa, the Triangle Hotspot, Homestead 2, and the East Field. The experiment design was deliberately provocative. The team hypothesized that stimulating the environment might induce observable phenomena. To test this, a series of controlled perturbations was introduced, including the launch of high-speed rockets, the release of thermal plumes from a hot air balloon burner, and the operation of multiple active sensors in overlapping fields. These perturbations served as triggers while LiDAR, thermal imaging, infrared cameras, spectrum analyzers, radiation detectors, and GPS receivers recorded the system's responses in real time. This approach mirrors methodologies in experimental physics, where environmental excitation is used to probe the properties of complex systems. The results were as unexpected as they were revealing. LiDAR data consistently detected a massive cone-shaped volumetric anomaly extending nearly 2,000 feet above the Triangle region, an area already associated with numerous unexplained events. In multiple instances, vertical laser beams projected upward were abruptly terminated at this altitude, implying interaction with a medium of non-atmospheric density. Such behavior is inconsistent with normal atmospheric scattering and absorption phenomena and suggests the presence of a structured field or material interface. Similarly, mobile LiDAR surveys identified a 300-foot vertical spire in the East Field, coinciding with an area of repeated GPS signal loss. The spire's geometry and persistence across multiple scans strongly indicate a fixed spatial anomaly rather than a transient artifact. The GPS anomalies themselves constitute a critical data set. Over the course of more than 40 drone flights following a standardized in and out trajectory, signal loss occurred at precisely the same coordinates, often accompanied by transient data voids. These voids are statistically improbable under normal satellite reception conditions and suggest localized interference with electromagnetic propagation. Possible explanations include ionospheric disturbances, electromagnetic field anomalies, or the presence of a medium that refracts or absorbs GPS frequencies. Notably, the points of signal loss align spatially with both the vertical spire and the borehole anomaly, suggesting a systemic linkage. One of the most intriguing findings involved the SLAM Simultaneous Localization and Mapping LiDAR system, a portable device that allows real-time 3D mapping of complex environments. During multiple surveys, the SLAM unit returned data from beneath the surface, an impossibility given the device's reliance on infrared light, which cannot penetrate solid rock. These subsurface returns aligned with known anomaly coordinates and mirrored ring-shaped structures detected in aerial scans. The congruence between above-ground and below-ground features is striking and bears resemblance to theoretical models of traversable wormholes, which predict toroidal structures with correlated spatial distortions above and below the event horizon. Thermal and electromagnetic data further enrich this picture. During burner experiments designed to heat localized volumes of air thermal imaging, recorded non-random distortions, including ring-shaped convection patterns and anomalous temperature gradients inconsistent with standard fluid dynamics. Additionally, radio communications experienced significant interference at altitudes corresponding to previously observed energy spikes approximately 5,000 feet above the triangle. These disturbances suggest strong field gradients or transient electromagnetic phenomena. Correlations between these anomalies and UAP unidentified aerial phenomena sightings, reported by visual observers and recorded by night vision equipment, hint at a possible causal relationship between energetic events and aerial manifestations. Another data stream of significant interest came from radar and optical tracking of launched rockets. In multiple instances, rockets vanished from both visual observation and instrument tracking for brief periods before reappearing. One rocket appeared to freeze in midair and exhibited discoloration indicative of microwave radiation exposure. These anomalies occurred in spatial and temporal proximity to measured electromagnetic signals, including a persistent one. 6 gigahertz transmission originating from above, Homestead 2. The interaction between launched payloads and these environmental signals warrants further study, particularly in the context of plasma physics and potential non-terrestrial signal sources. Data fusion across sensing modalities revealed deeper layers of complexity. Aerial imagery captured anomalous light sources emerging from Dry Gold's Creek, a site associated with previous electromagnetic dead zones and biological anomalies. Ground-penetrating radar data suggested high-velocity impacts into the mesa, potentially indicating the introduction of foreign material or structures at some point in the past. Collectively, these observations support a hypothesis of long-term, possibly engineered alterations to the ranch's subsurface and atmospheric environment. The volume of data generated by these operations is staggering, measured in terabytes and comprising billions of individual data points. Traditional analytical methods are insufficient to parse this complexity. To address this, the team deployed the Athena AI Analytics platform, a machine learning system designed to detect patterns, correlations, and anomalies across heterogeneous data sets. Athena's capabilities include time series analysis, spatial clustering, signal correlation, and anomaly detection. Early results indicate statistically significant correlations between LiDAR-detected structures, GPS voids, electromagnetic spikes, and UAP sightings. For instance, Athena identified recurring temporal patterns and anomaly, occurrences that suggest cyclical or reactive behavior potentially tied to external environmental variables or internal system dynamics. Data visualization has proven crucial for hypothesis generation. Three-dimensional reconstructions of LiDAR data reveal geometric structures that cannot be explained by known natural processes. Volumetric modeling of the mesa anomaly shows discrete density gradients inconsistent with typical sedimentary formations, while surface scans highlight non-random alignments of anomalous features across the ranch's geography. These alignments may indicate a larger integrated system rather than isolated phenomena. Furthermore, trajectory modeling of UAP sightings relative to known anomalies suggests potential vectoring behavior as if objects are being influenced or guided by underlying fields. Future work will focus on expanding the instrumentation suite and refining experimental protocols. Plans include widening the borehole to 1.5 feet to allow insertion of more complex sensor arrays, including neutron detectors, muon tomography instruments, and hyperspectral imagers. These tools will provide deeper insights into the composition radiation profile and potential energy emissions of the subsurface anomaly. Additional airborne platforms equipped with synthetic aperture radar SAR and interferometric systems will improve volumetric resolution of atmospheric phenomena. Simultaneous multi-frequency transmissions will probe for nonlinear electromagnetic interactions, while atomic clock arrays will test for time dilation effects, a key prediction of space-time curvature models. The long-term objective is to integrate these disparate data streams into a unified model of the Skinwalker environment. Such a model would incorporate electromagnetic field mapping, volumetric anomaly, reconstruction, particle flux measurements, and temporal distortion data to form a comprehensive picture of the ranch's physical system. Whether the anomalies represent unknown natural processes, engineered structures, or manifestations of non-terrestrial technology remains an open question. What is certain is that their consistent detectability, repeatable behavior, and measurable effects on instrumentation make them a legitimate subject of scientific inquiry. Skinwalker Ranch stands at the frontier of multidisciplinary research. It is a natural laboratory where geology, atmospheric science, electromagnetism, particle physics, and artificial intelligence converge. The anomalies observed here challenge foundational assumptions about the nature of space, time, and matter. They demand new models, new tools, and new ways of thinking. And they offer a rare opportunity, the chance to study phenomena that may extend beyond the boundaries of current scientific paradigms. The integration of advanced sensing technologies, rigorous experimental design, and sophisticated data analytics has transformed the investigation of Skinwalker Ranch from fringe speculation into empirical science. Each measurement, each anomaly, each unexplained signal adds another piece to a puzzle that may ultimately redefine our understanding of the universe. Whether the answers lie beneath the mesa within the anomalous fields above the ranch, or in dimensions we have yet to perceive, the tools of science are bringing us closer to the truth. And as the data continues to accumulate, one thing becomes clear: the mysteries of Skinwalker Ranch are not random. They are structured, they are persistent, and they are waiting to be understood.